All right. So we're basically basing this off of yesterday's, and so that's why we kind of had an easy day yesterday, because I told you guys I wanted to really work on that. So what we're trying to do now is we're going to kind of put together summation notation and Riemann sums. Who should I go with? Who haven't I called on for a while? I have not called on Lauren. Lauren, I don't think I've called on you for a while. Do you think you could help me out with a question? Excellent, thank you. What's a Riemann sum? Because if we're talking about putting together summation notation Riemann sums, it's kind of key that we know what that actually is. And I'm not looking for definition, just, do you remember what a Riemann sum is? Nice. Very nice. Very nice. Yeah, that's a good way to explain it. So what we're going to do is we're going to focus on the rectangles only. Mainly because rectangles are easier for us to kind of work with, or easier to understand even. But that was a perfect way to say it. So let me... Well, that didn't come out very big at all. This is the problem that we're going to try to work on. Our goal is going to be to estimate that area that's shaded. So we've got y equals square root of x, and we're going to go from 0.5 to 3.5. And I mean, we could just totally estimate and just kind of count squares and everything, but we're trying to go about this logical way to try to find exact answers, and we're working our way up to that. So if you guys worked ahead at all, because some of you guys are pretty diligent about using Khan Academy to watch videos and notes and everything, I thought it would be smart for me to kind of mimic Khan Academy's notes for these sections, because if they're confusing at all to you, then you can kind of see the same information from multiple ways. So I took a lot of these screenshots from their notes, so that if you guys are having trouble with this, you can kind of look at it again from a different perspective and then, help you out. So this is the problem we're going to focus on. And if we are going to use Riemann sums, this is one example of what we could do. So we're going to kind of make this one relatively, basic. We'll go with 4 rectangles. Anthony. Wait, no, I feel like I called on you already this week. I need somebody else. Okay, Zoom is strange. It does not put it in alphabetical order. Sydney, how about you? How's your internet working today? Okay. Well, if it makes you feel better, I keep getting random messages saying my internet is unstable, so. What I was hoping you could tell me is, from the other day when we did these rectangles, do you remember if this picture is left endpoint or right endpoint? Okay, so when I'm looking at each rectangle, I'm going to kind of try to figure out how the height was decided. So if I'm looking at rectangle number 1, perfect, because the right-hand side of the rectangle is on the function. And if you look at each rectangle, it's set up that way. Okay, good. And these are kind of a lot of the details why I didn't want to rush through this topic, because it's just like so many little things. First thing I'll try to clarify is I call it right endpoint because that's how I was taught it, and that's how our Larson textbook phrases it. AP doesn't call it right endpoint. It usually refers to it as a right Riemann sum. And I mean, like, you can kind of figure it out just from the various words. But the Riemann sum refers to the fact that we've got the shapes, and then the right means the right-hand side. So I usually refer to it as this right endpoint, but do know that these are the same things. Sam? Like, what are we... I'm trying to figure out the best way to ask this question. What are we trying to do with this problem? Like, to get the answer, what are we doing? That's a great answer. That's a great answer. That's exactly what I was looking for. And so I'm trying to tie this into what we did yesterday. Basically, what we are trying to do is we're going to find the 4 areas and add them up. Now, if we want to put this in perspective in terms of yesterday we used summation notation. We did the sum with my terrible sigma symbol. And we are going from 1 to 4, but the sum means we're adding them up. And so if we look at A1 plus A2 plus A3 plus A4, we're adding up the first 4 numbers, 1, 2, 3, 4, of the areas. So this Riemann sum problem can be written like that. Now, are we okay with that? Does anybody want me to, just like I don't want to get to too many details too quickly. Once you understand the layout of these problems, they're all the same. Okay. Well, then let's discuss this area, right? Because it's not a formula for area. Like, the only formula we have is square root of x. Carson, how do we find the area of the rectangles? Oh, your microphone's going weird today. That's all right. Marissa? Although, Marissa, you're on there twice. I'm not sure if yours is working either. Oh, you're on there 3 times. That's not a good sign. Oh, but yours is working. That's weird. Okay. How do we find the area of the rectangles? Yeah. Oh, okay, yeah. We'll get to that detail. That's for sure. You're correct on that. How do we find the height of each rectangle, though? Okay. Yeah. You have the right idea. Yep. That's the right idea. I know you were trying to give me details, that's totally cool. You're basically finding the height of the rectangle with the function. So if we want to use a summation formula, we actually have to have formulas written in there. So I'm going to kind of base it off what you said. You said multiply the width, which was 0.75, and multiply times the height. Now, here's the weird part. The height, I can't just write as square root of x. maybe I'll try to ask it like this. Chase? Chase, how come I can't write it as square root of I? Oh, no, that's actually pretty good logic right there. The I that we used every time before this was for imaginary numbers. This I actually just stands for iteration. I mean, like we could write an X, but I just didn't want to confuse you with the other X. Okay, that's okay. Does anybody know what I'm trying to ask? Like, why can't I just write square root of I? Because square root of X was the height. It is. What would be the first number I would? I'll just stick with you, AJ, if that works. What would be the first number I plug in for this summation? Because my summation goes from 1 to 4. So the first, you'd plug in 1. Well, you meant 1, yeah. The bottom number is where you start. But yeah, that's right. It wouldn't actually matter which number you started with, I guess. But we would start with 1. And if I go look at this picture, if I plug 1 into the equation, that's not the correct height. The first number that we plug in has to be 1.25 because that's our first height. Our first height is at 1.25. So like this summation, what I actually need to do is I need to write an equation so that my first value plugged in is square root of 1.25. So here's what I'm going to do. My first value, my first x value, you know what, I'll erase the square root for right now because that's actually not as important. The first x value I'm going to plug in is going to be 0.5 plus the width of the rectangle, which was 0.75. So I'm going to have the starting number plus the width of the rectangle, I. And then what this will do is for each I number I plug in, 1, 2, 3, and 4, I'm going to start at 0.5 and then add 0.75 each time. Now our goal was to have the square root of x, so these numbers take place of x. And then this formula would get us the correct answer. And I'm absolutely going to write more details down below. I wanted to do this specific problem before we talked about like a general formula. So for this specific problem, does anybody want me to go over, talk about something I just wrote down? And I know sometimes you guys don't want to speak up. You could even type it in if that, you know. Oh, go ahead if somebody's asking. Yes. Yep. Okay. So I'm not sure how this is going to work for my recording, but let me show you how to calculate this on the calculator, because that's actually going to be pretty important. Because if you learn how to write something complicated, like say you decide you want to do more rectangles, it's really helpful for you to just be able to change a couple numbers and be able to find a different answer. So let me stop sharing the notes and switch to the calculator. And I'm just going to kind of hope that that will transfer. Oh God, that doesn't even fit at all, does it? Well, that's a fail. Can I change the size? Well, this is what happens when you have a free version. Oh, there we go. There we go. So I want to go over how to type this into the calculator with you guys. So if you guys have your TI-84 with you, it's definitely good to learn this. So I'll give you a second to get it out if you have one. Now, I'm sure there's an online summation calculator as well. So, you know, if you have that, that's fine. But the thing with the 84 is it's really hidden where it is. So what you're going to want to do is it's under F2. Like, it's not labeled at all, but it's under F2. So F2 is in green, so I want to use the alpha button in the window. And it kind of brings up a secret menu. Number 2 is for summation. And if you have your calculator updated, it should show this. If you have a TI-83, this setup isn't going to work. And you're probably not going to want to try it on the TI-83, just because it's really complicated to type in. So if your calculator shows this version, that's probably the best way to go about it. So I want to type in from I. To be able to use the letters, the alpha key has to be kind of active. So if you can see that little flashing A, that's the alpha key. So it's like the alphanumeric keyboard. Okay, so I goes from 1 to 4. And I want to do 0.75 times the square root of 0.5 plus 0.75 I. Now you'll notice that it's not flashing with the alphanumeric keyboard anymore. So you have to hit the alpha key to use the letters. The X key is the only one that actually you can type in. You know what? I could have used an X from the very start. That probably would have been easier, but whatever. Either way, you just hit enter. And then this would have given us the approximation to our rectangles that we had drawn for that picture. Now, part of the reason the answer is, you know, not very nice and neat, even though it's like rectangles, is because we were using square root of x. So square root of x is definitely not great numbers. Anybody want me to repeat where I found things on the calculator? Because I'm actually not going to have much time to show you calculator things today, just because these problems go slow. So this might be the only one I can show you the calculator for. Okay. If you want the I, hit the alpha key. So the alpha key is just to unlock the alphanumeric keyboard. But basically, you'll notice all the letters are written in that same color. And so the I is the one above x squared. And you don't have to use an I. You can just use this button that says xt theta n. Like you can use an X, and it still works. As long as the variable you type in there is the same in both spots, you're good. Okay. Then I will minimize the keyboard calculator. And I'll put our regular notes back up here. Okay. So obviously, if you need to, you could take the time and do this like logical process each time to figure out the answer, but that actually gets pretty complicated depending on the function. So what we want to do is we want to be able to do this for any problem. So what I want to do is I'll put this up so you guys can copy it down and then highlight, star it, whatever you want to do. You're going to need these formulas. And I will 100% explain what everything stands for in these problems. Okay, the one that we just did was the right Riemann sum. And you know what? I will show some patience this time. And I will hold on for a minute because I'll wait till you guys write it down to talk about it. Oh, you guys don't really have like a little hand raise thing that you can do or anything either, huh? I was wondering if there's a nice simple way for me to figure out when you're done writing it. Whatever. Okay, so we just did the right Riemann sum. And like, remember we had 4 rectangles, so we went from 1 to 4. Rather than try to refigure everything out, if we're doing a left Riemann sum, if we have 4 rectangles, we're going to go from 0 to 3 instead of 1 to 4. And so I'll go up and I'll try to show you how come that works. So remember how we we started with we started with 0.5, but we needed the right-hand side of the rectangle, so we added 0.75 onto the first term. Well, for left endpoint, we want the left-hand side of the rectangle. So what we do is we say the first term is I equals 0, because then that would do 0.5 plus 0 of the widths. And then your first term would end up being the left-hand side. So rather than try to like calculate different things, we're basically going to always use these same formulas and the same ideas, but we shift the numbers for left instead of right. Okay, so the n. Let's start with the n. Oscar, how about you? Do you remember what the n stands for? Perfect. So it's the number of intervals or rectangles. Yeah. It doesn't matter how you think about it. I just know that you're going to see different wording in problems. So n stands for how many times you've divided it up. Delta x is the width of each rectangle. And obviously it's the same in both formulas. I just figured I'd write on the left one. The width of each rectangle, and here's a formula if you like formulas. B minus A divided by N. So B minus A tells you how wide your piece is, divided by n would be how many rectangles you want. Okay, x sub I. That's basically the last part on here that's usually kind of hard to decode. Probably the most confusing for most people when you're looking at the formulas. X sub I is basically just like, you know, you have to plug a number into the function to find the rectangle height. So x sub I is which number you plug in. X sub I can be found by doing the starting value, so that's A, plus delta x times I. Now, I will definitely kind of add on to this. F of x sub I means that you put this formula into the function you're given. So I want to do my best to make this clear for today, because we 100% need to figure out Riemann sums to be able to do definite integrals tomorrow. Tomorrow is going to be our calc versions. So that's why I want to go slow today. Does anybody have any questions on anything I wrote up there or anything that looks confusing to you? Because now is a good time to ask before we try doing example problems together. I've got 4 problems. I don't have a clue how long it's going to take us. Okay. Does anybody want me to leave what's up there for a little bit for you to copy down? Or maybe you could do a screenshot or something. Oh, go ahead. Was somebody trying to say something? That's a good question. I've never actually run into that. I don't know if you'll ever be asked to do... So the midpoint questions that you will get on the AP test would only be like simple rectangle ones where you wouldn't want to use a summation formula for. So the summation formulas that we're working with now, you generally only use them if you start having lots of intervals. So, like if we decide to have 100 rectangles, that's definitely a benefit to use a formula so that you don't have to hand calculate everything. So I've never seen a question be asked about midpoint. You could modify this formula to work for midpoint, but the modification you'd have to make would be the A plus delta xi, and we don't want to do that just because it's going to look too complicated to be a benefit. But yeah, we could modify it, but I've never seen that actually. So I'm assuming no. The last 30 years of AP tests, I guess I've never seen a question for a midpoint Riemann sum. That's a good question. Okay, let me put up one for us to try then. So I'm hoping you have those formulas handy. I'm flat out not expecting you just to know them. So again, I'm trying to mimic Khan's notes so that if you guys go back into them later to look at them again, that you know, it'll be helpful to see it from multiple viewpoints. So let's do this problem. So we actually don't need the picture. You know, I have the picture there for us, but we don't need it. The function we're using is 0.1 x squared plus 1. We're going from 2 to 7. We're using left Riemann sum and 10 intervals. So that's the information we need. So I should start probably by writing down the generic formula. And again, we actually don't need the picture at all. I know some people like that to kind of help them process. So left endpoint, it's going to be the summation from 0 to n minus 1. Chidera, what number should I put on the top of this summation? Perfect. It's the number of intervals minus 1. And that's only because it's left. I don't know if I should write that. Okay, so sum from 0 to 9. Delta x. You know what? I'll just write the generic one first. That'd be smart. Okay. Delta x. Who haven't I called on? Ariana? Have I called on you? I apologize if I have. Do you think you could help me figure out delta x, the width of each rectangle? Okay. If I scroll back up, I won't just because of the recording. Delta x can be found by doing b minus a divided by the number of intervals. So, are you getting confused by the b and the a and the n, possibly? Or is this just like kind of information overload? Do you want me to help you organize it? Okay, I will do that. So delta x can be found by doing, when it gives you an interval, like the 2 to 7, that's our a and our b. A and B are usually referred to as the beginning and the end of where we're looking at. So each rectangle, so from 2 to 7, would cover 5. So it's 5 units. How many intervals are there, Ariana? Yep. 10. Yep. So n means how many rectangles or intervals or subdivisions is what wording they used. Okay, so delta x is going to turn out to be a half or 0.5. So there's absolutely nothing wrong with kind of breaking down this problem and trying to find each thing on its own rather than like feeling like you should just know how to do this problem off the top of your head. So delta x, take the time to go figure out how to find delta x separately because, you know, if you need to, that's kind of why I tried to write down the little formulas. Okay, so delta x is 0.5. Okay. X sub I. Let's find that before we find f of x sub I. Bella, do you think you could figure out help me figure out x sub I? And if you want, I can certainly refresh you of the formula. Close. Oh, you said 0.5. Yes. No, you're good. In my head, I heard 0.25. So x sub I is going to be your starting value plus the width times I. I want to plug this into the function we were given. So I want to figure out f of x sub I. Oh, open up the chat here. Carson, it's okay. The one big difference I've noticed with Zoom over Google Meet is that when I share my screen, I can't see anybody else's. So it's okay if you have your cameras off. If you had them on, I wouldn't be able to see you anyway, so that's okay. Who haven't I called on yet? Aiden Rage. I haven't called on you for a while. What would be f of 2 plus 0.5i? F of 2, oh yeah. I don't know if is it coming out on your screen okay? I'm trying to get all the info on one page, and it's hard. So f of x sub I is the last thing we need to figure out. X sub I is 2 plus 0.5i. So f of 2 plus 0.5i. Oh. Perfect. Perfect. You're going to put 2 plus 0.5i in place of x. Correct. Okay. I'm really bad about writing 0 point something, so I'm hoping you guys kind of are following that okay. I've never liked writing the 0 beforehand. It just looks cleaner to me without it, so I've always preferred it. I will tell you, Khan Academy. So I tried some of these problems out ahead of time. Do not use brackets in Khan Academy. It doesn't recognize brackets. It wants you to use parentheses only. Now, this is your answer, FYI. Now, you may be asked to type that in your calculator to get an answer, which is fine, but you're not going to have to do these by hand. Alex Ann, let's ask you the big question. Are you ready for the toughest one of the day? You sound wide awake, so you are absolutely ready. I like it. So where we're leading with this is we want to do a lot more rectangles than just 10. What would change in my equation if I changed it to, say, 1,000 instead of 10? That's partially correct. So instead of 9, it would be, I can't even remember what I said. I think I said 1,000. So it'd be 999. But then what else would change would be this 0.5. Because the width of each rectangle would be slightly different. So instead of being 0.5, it would be 5 over 1,000th, which is, I believe, 0.002. So the nice thing about these formulas is they're set up so, 10 rectangles would give you a pretty accurate estimate. But clearly 1,000 rectangles would give you a really exact estimate. And so this is absolutely leading up to tomorrow, where we're going to have an infinite number of rectangles. And this is only going to work if you guys are okay with how these questions are set up. Here's what I was, I didn't even give you guys time to ask. Does somebody have any kind of questions on the one that we just did? I'm going to erase the 1,000 rectangle info, because I don't want you to confuse that with the problem we actually did. Does somebody have any questions on what's up here? Once you get the hang of the individual little parts, it's not bad. Should I put a... let me shut off my ringer. Would you like me to put up a couple more examples to see if you guys could figure them out on your own? The equations? Probably. I mean, we only have 15 minutes left, 14 minutes left. Okay. I didn't know if you guys would just prefer time off. I suppose I should make it big enough so you can actually read it. Let's see if I can accomplish that. Well, I think it might be the biggest I can get it. Okay, so here's two examples. I'll give you 5 minutes, which might not be enough for you, but that's okay if it's not. I'll give you guys 5 minutes. See if you can figure out the equations. You do not need to copy the pictures. The only thing you want to write down is the formula and information. And is this big enough for you to read? Okay, because otherwise I could delete the pictures and kind of just write the information down. In case anybody is in here that wasn't in here at the beginning of the hour, don't forget to go mark yourself in for attendance. Yes, you're supposed to do it every day. I know. I do my for the people that forget to do attendance. I do my best to remember if you were in class. But I won't lie. I paid very little attention to that. So I think if I remember correctly, I marked you present because I believe everybody's here today. So. I don't know if that's enough time, but let's just go with it just because I don't want to run you guys long. Okay, so again, the picture is actually kind of irrelevant. I just wanted the information. So, example number 1. Let's see, we are using a right Riemann sum. So, right Riemann. It's going to be the sum from 1 to the number of intervals. We were told there are 9 intervals. Delta x is supposed to be the width of each interval. Well, delta x is going to be 7 minus 1 divided by the number of intervals. And that gives me an answer of 2/3, 6/9 or 2/3. Generally stay away from decimals if you can help it, unless it's a terminating exact decimal. And then I need to multiply by f of x sub I. So let me figure out x sub I first. X sub I is going to be the starting value, 1, plus the width times I. F of x sub I is me plugging this answer into the equation given. Oh, I guess it's actually g of x sub I, but that's fine. So put that information in place of x. Okay, so this is what I am multiplying by. Now, a cautionary answer on this one. So, again, just to find examples that are set up already ahead of time, calc examples are hard to just make up off the top of your head. So I went and took a lot of these from Khan Academy just to kind of check it out for you guys ahead of time. A lot of multiple choice answers, aka the AP test. So that's why it kind of concerns you. Because honestly, I wouldn't care how Khan Academy is set up, but the AP test is a lot of multiple choice. Multiple choice answers won't write a fraction within a fraction. Like they consider that improper, and so they won't write that answer. So the actual answer that would be written on multiple choice tests would be similar. But instead of having 5 over 1 plus 2/3 I, you are going to multiply the top and the bottom of the fraction by 3 to cancel out that thirds. So your f of x sub I would actually be 15 over 3 plus 2I plus 2. This would be the answer that would be your multiple choice. So you're going to have to look out for that. Does anybody want me to explain how I figured that out or went over that? Because these are details that are going to be important to you. Okay? Okay, so here's the second one. Information's down below, but really tiny. Also right. Shoot, I wanted one right, one left. Oh well, my fault. Right Riemann sum, 10 divisions, 2 to 7. Equation is 1 over x plus 2. That's the same equation. No, it's not. I didn't even notice they were that close. Shoot, I really would have picked a different example because I had some more to give you. Okay, but it still doesn't matter because I want you to go through the process. Right Riemann sum. So Riemann sum, the right Riemann sum again, starts at 1 and goes to the number of subdivisions, so 10, times the width. Okay, well the width, so delta x is going to be b minus a divided by number of subdivisions. So 0.5. Okay, 0.5 is the width. F of x sub I is the next thing I need, so I usually figure out x sub I first. X sub I is the starting number, 2, plus the width, 0.5, I. And I'm going to put 2 plus 0.5 I in place of x in the function. So f of x sub I is going to be 1 over 2 plus 0.5 I plus 2. Now I'm trying to remember this one. There's actually nothing wrong with this answer, but if I remember correctly, this was, again, you know, they cleaned it up for multiple choice, which they sometimes do. If I remember, they multiplied the 0.5 out. And you don't need to, I just want to show you how it was done. So if you multiply the 0.5 out, you would get this. And 0.5 and a 0.5 within a fraction, it'd be better if, you know, they weren't fractions. So we're going to double the top and the bottom so that they're not decimals or fractions. So you're going to have to look out for this. Like these are annoying details that you'll run into sometimes. This would have been the multiple choice answer. Even though the one in pink is 100% correct. And the one in the pink is what I care about because that's what you're going to type in a calculator. So I'm not concerned with you simplifying things because you're generally not going to need to do that. Okay, we went pretty much right till 10. If you guys can, to give me an idea of how well you're doing on this topic today, like just what we did today, if you could give me a 0 to 5, how well you're doing in the chat window, that would be awesome for me to know how I should proceed for tomorrow. Okay, and I'm hoping obviously the numbers will go up, you know, after you practice the homework, because that's the idea. The more you do of these, the easier they feel. But okay, good to see. Because tomorrow's is going to be building off of this. All right, perfect, you guys. Appreciate you coming. That was definitely a long class because I knew there was a lot of details. I will see you tomorrow. Thank you for coming.